All right, we're taking a look at the area of oblique triangles. Oblique just meaning not a right angle triangle. So it's a little bit more difficult to do the half base times height method. We're going to look at Heron's formula, and we're going to look at area given side angle side, otherwise known as the sine area formula. So we've went over this in laws of sine and law of cosine, but it's very important to know how to label a triangle. The only thing that matters is that A is opposite from angle A, so side A is opposite from angle A, that side B is opposite from angle B, and side C is opposite from angle C. You can label it whichever way you want, A, B, and C is not necessarily in any particular order. If you move where the angle is, you just need to move where the side is. Remember, all three of these angles add up to 180. So if you're missing any information, you can always, if they've given you two angles, you can use that to get the third angle. These triangles are not right triangles, so you're not putting side C opposite from the 90 degrees. They are oblique. So whenever in a problem you hear oblique triangle, it just means it's not a right angle. They can be acute triangles like the one you see here, or they can be obtuse triangles like this one. Again, it doesn't matter which side you label as A, B, or C, just as long as side A is opposite from angle A, side B is opposite from angle B, and side C is opposite from angle C. So let's take a closer look at Heron's formula. Heron's formula states that we have the square root of this magical number S times the difference between S and A, S and B, and S and C. This magical number can be found by taking half of A plus B plus C. In order to apply Heron's formula, you must have all three sides. So it's either you're given all three sides or you can solve for all three sides. Either way, if you're going to use Heron's formula, you have to have all three sides to start off. Here's an example of a triangle with all three sides. Let's find the area. So this triangle is called XYZ. We're still using, you could call it ABC, you can rename it if that makes it any easier for you. But we're just going to use it as XYZ. Here we already have all three sides, so we're going to go ahead and find our magical number first. So our magical number is going to be half of 36 plus 22 plus 20. Here's how you know it doesn't matter which side you call A, B, and C. 36 plus 22 plus 20 is the same thing as saying 20 plus 22 plus 36, or 22 plus 20 plus 36. No matter which way you arrange it, you're just adding them all together and taking half of the sum. So some people will just say S is half the sum of all three sides. Our magical number S is 39 for this example. So when we plug it in, we have 39 times 39 minus A, 39 minus B, 39 minus C. Or in this case, 39 minus Z, 39 minus Y, and 39 minus X. So as we plug the sides in, we just need to put all this in the calculator, and we get that our area is 194.4. Our units are inches, so we're going to make sure that we put units of inches squared for our answer. Now, applying area of a triangle given SAS, or the sine area formula. It is the same formula, just shown three different ways. Area is equal to half BC sine A, or half AC sine B, or half AB sine C. It's the two sides with the angle in between. So in order to apply these formulas, you must have two sides with the angle in between, side, angle, side. Here's an example of a triangle that is side, angle, side. You'll see that we have the two sides here, the 5 and the 7, and in between that we have an angle of 49 degrees. So that allows us to use these formulas. So in this case, we have B and C and angle A. So we're going to use that that first formula. So we have half 5 times 7 sine 49. So that's half of B, which is 5, times C, which is 7. And then sine of the angle 49. As usual, when you're dealing with degrees, you need to make sure that your calculator is in degrees. A lot of calculators, their default mode is radians. You might have to go into the mode and change it to degrees before you start. Here we have an area of 13.2. They did not mention a unit here, so if it was in feet, it would be feet squared. If it was in meters, it would be meters squared. You could always, if you want to add, you could put units squared if they don't give you any units.